Hello everyone. So today our topic is about three ways of heat transfer. Okay, as we have said before, we have two parts in the thermophysics. The first part is about using a microscopic views to see the particles and molecules, and another part is about using the heat transfer or like using the daily life view to see about the thermophysics. Okay, so today's view is about using your daily life view to consider about the world and how the heat can transfer. Okay. So let's move to the first part. It's the first way of transfer heat. Okay, so it is called thermal conduction. So what is a thermal conduction? And I'll give you an example about this. Okay, so when winter comes and you are using a bottle with hot water, like here. Okay, maybe a bottle of hot water, and why it is very maybe warm for you to hold it? That is because your hand just put it directly on the bottle, right? And I remember when I was a child, and my mom just used a sock to cover on its surface. And using the sock, you can find it's not very hot, but a little bit warm, right? And I remember this, so I can say that that is because my hand just put directly on it, and it can make me warm. Okay. So for thermal conduction, there are many other examples, like in the winter when you're at school, maybe maybe there are snowy in the school, right? Snowy everywhere. And once you go to your seat, you'll find there is very cold on your ass, right? So that is because the seat just cooling down in the very cold temperature and just ass just directly contact with the seat, right? So we can say here we have several examples. We have a conclusion that they are all zero in distance contact, right? So this is for thermal conduction. They're just zero distance contact, okay? And the ways of heat transfer, and the direction of heat transfer is from the high temperature to low temperature, okay? Here we can set high temperature to low temperature, okay? So here is for thermal conduction. I think it's very easy for you to understand, right? It is mostly appeared in our daily life using the thermal conduction, okay? Okay, so let's move into the next part. It's called convection in the liquid. So convection, this word, maybe most of the time it appears in geography. Okay, the convection, like we can say the global convection, like the convection in a city, like other many kinds of convection. Okay, so maybe you are fine. It is conducted with a word raining, right? Okay, so like here you can find an example here. Like here's a beaker filled with water, and we are using a Bunsen burner on its right bottom. Okay, and here you can find on its right, once the water is heated, you can find the volume increases, like they have expansion, and then their density, because density equals to mass or volume. Once the mass doesn't change, volume increases, the density decreases, right? So density increases means that the water just becomes less, maybe lighter than other liquid, so they're just moving upward. And for on the left, you can find here is a cold water, so maybe it's just moving downward, okay? And once it's moving downward and once right moving upward, you can find here there are less water. And here there maybe converted for more water, okay? And then the water will also running like this way. And you can find here we have maybe converts many water, and here we have lost many water, and here is also a water transfer direction, okay? So you can find here in a bottle because of difference, right? Because there's a Bunsen burner, there's not. So there is a loop inside of this, right? So then we can make a conclusion about the liquid. First, we have maybe the different temperature, or what we call temperature difference. So you can find here on the left and on the right, you can find here, because of the temperature difference, we have one upward flow and one downward current, right? So this is for temperature difference, okay? And second one, you can find there must be a height difference, right? If there's not height difference, maybe the current cannot transfer very easily like this way, right? So this is about heat transfer or height difference, okay? And the third way of this, we can say that because of the height difference, temperature difference, it can form a loop, right? So here we can say it form a loop like this way. Okay, so there are three basic conditions and properties for convection in liquid, okay? So please remember this, it's very important, okay? This is for convection in the liquid. Okay. And the next part we have to discuss about another example, like a convection in the gases. As we knew that gas and liquids are both current, so they have a very similar property, okay? And here you can find in the winter, when the winter comes, and here is a heater or radiator in the room, right? Can give you the heat. And once you place the heater at the bottom of the room, you can find on the right, the gases just moves up, right? Because here it heated and the density becomes smaller and just moves upward, right? And for here, you can find the cool air, it just sinks, right? So one rises, one sinks. We can say that here it converges for more air, and here just like some air just escape or just sinks, right? So here you can find there is a direction for the air transfer, right? Because here is more and here is less, okay? And also at the bottom, because there converges for many air particles and there just losses many air particles because it just rises, right? So here is also direction for the air transfer, like from the left to the right, okay? So here it forms a loop. Like here is a very from the heater and we upward and then turn left and turn moves down and then turn right. Okay, a very like total circle. Okay, so we have also some properties in here. First property is temperature difference, right? Because there's a heater and there's no heater, right? So the first property is they have a temperature difference. And second, you can find here you just height difference, right? Because here is a top or the ceiling of the room, and here's a room or floor of the room, right? So here's also a height difference, okay? So here's for temperature difference and the height difference. And the last, we also has to form a loop, right? So here's the convection, okay? So please remember there are the three properties, okay? And at last, we are going to the radiation. And for radiation, we heard most of like using the infrared and using the ultraviolet, right? Because the sun can just release the infrared and the ultraviolet rays, right? So I remember when I was also I remember when I was a child, I went to Malaysia, and I just swimming all the time because at that time I have a very big swimming pool under my house. Okay, and then every day I goes out from my apartment and then just go to the swimming pool and swimming. And after that, I found my back is burned, it's sunburned. Okay, very injured and very hurt. Okay, so you can find that radiation is a kind of heat transfer, right? It can just use a heat onto my back, right? And you can find it can also transfer in the vacuum, no need any medium, right? Because like the sun just in the space, right? There is a vacuum between the Earth and the sun, right? So I said that the radiation, first property for this is can just traveling in the vacuum, okay? And after that, we can say that radiation just have a distance between your body and the source, right? Can say that the distance between the receiver and maybe the the source, okay? And here is a very important two rules for the radiation. So please remember this, okay? So here, like, or most kind of radiation, or if you want to determine whether it is radiation or a convection, just please determine that. If it's just like the sun, it gives out heat, sometimes gives out heat, or gives out light. Okay. And just like a ball, like a sphere, just gives a heat and light from every corner, okay? Just remember here, maybe are the very common properties for this, okay? So after discussing about the radiation property, let's move into another view for the radiation. And here are two kinds of maybe two kind of metals here, right down in the sunshine. Okay, and here is a black and maybe dual color for a metal, and here is a silver color for a metal. And once you put them into the sunshine at the same time, you can find the black metal just increase the temperature very sharply. And for the silver and maybe light color, you can find the temperature just decreases very low, okay? And once you maybe put into the cooling room, you can find the black also decreasing the temperature very easily and it can very decreasing very quickly. And for the silver, it can maintain the temperature, okay? So for here, you can find temperature, they have a difference, right? Or they can have different ability to absorb heat and release heat, okay? So here we have a conclusion. After several experiments, we can say that for black and dual color, they're very easy to gain heat and lose heat, okay? And for silver, we can say that it's very hard to gain heat and lose heat, okay? Okay, this is for black dual and for silver, okay? Like this way. Please remind it. Okay. So maybe you can find once you are maybe you have experience to go to the rural places. And remember when I was a child, okay, I take a travel to the rural places near my hometown, and I found that maybe here you can find the farmer are using maybe like a white plastic just covered on the vegetables, right? So why they're using the white cover or white plastic to do this? So after this, you can find the white and silver, maybe close into the silver color, you can find it's more likely to preserve the temperature, right? So when the like summer comes, maybe the land is very hot and they are very hard to gain heat. So the vegetables cannot be burned, right? And then when winter comes, you can find the temperature is very low, right? So for the vegetables, they are very hard to lose heat because of this way. Using the plastic can help them to protect their temperature loss. Okay, so here there are this color using. Okay, so let's move into exercise. So here, please just try on yourself, please. Okay, so here you can set two other identical cars, one black and one white, are at the same initial temperature, and the cars are left maybe sunshine and their temperatures increase. During the light, the temperature decreases, right? And it said which car shows a greater rate of temperature increase and which car shows a greater rate of temperature decrease, right? So here we can find here are two kinds of temperature increase and decreases, right? Like different color like black or white, okay? So maybe right here you can find we have already talked before that black very easy to absorb heat and lose heat, and for the white or silver color it's very hard to lose heat or gain heat, right? So here you can find the greater rate for temperature increases must be black, and also here must be black, right? So here we're choosing A, okay? So here is our lesson for the thermal physics, okay? So maybe next time we are using another view to maybe have a discussion about thermal physics. Okay, so see you next time. Bye.